You are welcome to my channel. In today's class, we are going to concentrate on shapes of atomic orbitals. Atomic orbital is just like a region of space around the atom of an element, where there is high probability of locating an electron. Why do I use high probability? Because the electron behaves like a wave. In basic chemistry, we are made to know that electrons are arranged on the shells or energy levels this way. But in actual sense, an electron cannot remain at a particular defined area. It vibrates because it is wave-like. This wave-like nature of an electron is explained in the Heisenberg's uncertainty principle, which states that you cannot simultaneously determine both the position and momentum of an electron. You can't determine the position and momentum at the same time. If you want to know the position, you will know the momentum or speed. If you want to measure the speed, you can't know the actual location. A real-life example is the bee, the swarm of bees. If you have swarm of bees like this, note, you will find it difficult to catch one bee. If you want to catch this particular bee here, you will see that it will likely change location to this place. You want to pick this one, it will likely change location. And because it is always changing location, you are going to use a probability statement to decipher the location and the speed of the bee. That is how electrons are. And because of that, orbitals are defined as the region of space around the atom where there is a higher probability of locating an electron. Now, in chemistry, there are four kinds of orbitals. We have the s orbital, we have the p orbital, we have the d orbital, and we have the f orbital. The s orbital is the orbital of least energy. As you go down s, p, d, f, energy increases. And the energy content of each orbital determines the number of electrons it can hold. S orbital holds maximum of 2 electrons, meaning that it can hold 1 electron, it can hold 2. P orbital can hold maximum of 6 electrons, meaning that it can hold 1, it can hold 2, 5, and 6. D orbital can hold maximum of 10, can hold 1, 2, 3, 4, 9, and 10. F orbital can hold maximum of 14 electrons, meaning that it can hold 1, 2, to 14 maximum. Let's look at the shape. The 1 or 2 electrons present in s orbital vibrate to produce a spherical shape. And that is why s orbital has the spherical shape. And this spherical shape is spread along the 3 axes of space. Let's use this as the z-axis of space, meaning that this is negative z-axis. And let's use this as the x-axis. If this is positive x, we have negative x here. And now, y-axis is actually not represented on a plane. Y-axis is actually pointing inside the board and outside it. But we can represent it on this plane as this. This is y-axis, negative y. This shows that this side is pointing inside the whiteboard, and this side is pointing away from the whiteboard. So these are the 3 axes of the space. Remember, I'm talking about s orbital. The electrons in s orbital, when they vibrate, they produce a spherical shape, a cloud of sphere, which spread around the axis of space. Now let's move to the other orbitals. The other orbitals are known as degenerate orbitals because they are made up of orbitals that are of nearly equal energy joined together. P orbitals, for instance, are 3 in 1. We have px, we have py, and we have pz, each having 2 electrons. 2, 4, 6. You can see that the maximum is still represented here, 6 electrons. Now, the shape of p orbital is different from the shape of s orbital. This is s. The shape of p orbital is known as dumbbell shape. Dumbbell. Dumbbell is just like pressing this spherical shape at the middle and twisting it. That is dumbbell. We can represent dumbbell like this. After drawing the 3 axes of the space, the dumbbell is now represented here, but the dumbbell does not spread around all the axes. The dumbbell must align with one of these axes. If the dumbbell lies on x-axis, it means this is px orbital. This is px. If the dumbbell lies on y-axis, we have py. And if it lies on z-axis, we have pz. But I'm not going to draw all the p orbitals. Now let's look at d orbital. There are 5 d orbitals. dxy. We have dxz, dyz, dx square y square, and dz square, each having 2 electrons. And if you sum up the two, you are going to get 10. There are 10 maximum electrons in d orbitals. The shape of d orbital is double of this, and that is why it is called double dumbbell. Double dumbbell, or you can call it rosette shape. How do we represent the rosette shape of each d orbital along the axis of the space? Now, there's a logic to this. Let's now represent dxy first. dxy orbital. dxy. The alphabet that is not here is z, right? And the shape is double dumbbell. So the first dumbbell is going to the axis whose alphabet is not represented, which is z. So the first one goes on z. The second one is going in between the axes whose alphabets are present, x and y, meaning that the second dumbbell is going in between x and y axis. You can see this is the space where the second dumbbell will stay. So this is the shape of dxy orbital. dxz, we use the same logic for dxz. The alphabet that is not here is y. So the first one will go to y, and second one is going in between the two alphabets, x and z, right? This is z. So it goes here. The next is dyz, the same way, dyz. The first one goes to the alphabet that is not here, which is x, and second one goes in between y and z, which is here. Now, coming here, the logic changes a bit. X square and y square, meaning that the two dumbbells will lie exactly on x and y because of the square. So the first one goes to x exactly, second one y. So these are dxy, dxz, dyz, dx square, y square. Now the last one is dz square. Remember, this and this resemble. Z square means that the first one is going on z axis, and then where would we place the second one? Let us draw the first one first. The first one goes on z, right? We place it on z. Remember, there is no other alphabet here. So what do we do? Let's move to the first set. The logic we use there is that if there is no alphabet, we place the dumbbell on that axis. Like here, there is no z here. That is why we place this on z. And now, here in dz square, there is no x, there is no y. And there's not going to be any possibility of placing one dumbbell shape on both x and y. Like as a human being, you cannot be here and there at the same time. So what are we going to do? We are going to spread this dumbbell round so that it will touch both x and y. Is it possible? Yes, it's possible. Remember, this y here is pointing this way, away from the plane and inside the plane, and x is flat and z is standing. So we will make this z to stand at the middle so that we spread the dumbbell round so that it will touch only y and x. It is possible when it goes round this way. You can see that it is not even touching z, but it's touching x and y axis. You can see that this is just like a tube that goes round z without touching z. But as it goes round z, it touches both y and x. And this is the z square orbital. What is remaining is f orbital. Just like we have 5 d orbitals, we have 7 f orbitals, but their shape is too complex to draw. I hope you got value. If you did, subscribe to my YouTube channel, follow me on TikTok, and make sure you share this video as wide as possible.